Oh, now's the time. Balancing chemical equations. Let's take a little time here to look at how we can balance a chemical equation. But first, let me point out why it's important that chemical equations be balanced. Remember the principle of the conservation of mass? Atoms are neither created nor destroyed in a chemical reaction. If you start out with 10 atoms, you're going to end up with 10 atoms. The atoms may be rearranged. They may have different partners now, but you have 10 atoms before, you have 10 atoms afterwards. There's a conservation of atoms. They change partners, but the numbers you have are the same. You don't lose that mass. So, the equation better reflect the principle of the conservation of mass. The number of atoms you have as reactants should be equal to the number of atoms you have as products. So, we want to make sure our equations are balanced. That means playing around with the coefficients. And there are a number of techniques to use to balance chemical equations, and I will share with you some guidelines. There are other guidelines, but these are some of my favorite. Check this out. Number 1, balance one element at a time. You know, you read from left to right. We'll read equations from left to right. And when we balance the equation, a good thing to do is start with the leftmost element and move from left to right. And do it one element at a time. Put blinders on and focus on just one, balancing just one element at a time. Guideline number 2. If you incidentally unbalance an element, leave it alone. What I'm saying here is that you're focusing on only one element at a time. And as you change the coefficients around, you might mess up another element, and suddenly it becomes not balanced anymore. What this guideline is telling us, don't worry about that. Just focus on one element at a time. Okay, guideline number 3, make successive passes. You're going to be going over the elements within the equation, moving from left to right, and you're going to finish up all the elements, and then you're done with one pass. Go through and do it again, starting with the first element, and go through all the other elements, and then maybe even do a third pass. Let me show you an example. Here, look carefully. This is an equation representing aluminum oxide plus carbon gives rise to aluminum plus carbon dioxide. Right? It's a chemical reaction, and we're trying to represent it here using the chemical equation. And do not forget that the chemical reaction is a very dynamic process involving lots of motion. And here, it's just a snapshot. We're trying to, as best we can, to represent it on a piece of paper. All right? Now, we study this equation and we can see that it's not balanced. Check this out. We have 2 aluminums over on this side, and we have only 1 aluminum on that side. What happened to that second aluminum atom? Did it just disappear? No, it didn't. What's wrong is the equation's not balanced. It's not an accurate depiction of the reality. So we need to modify that. How do you do that? Let's focus on one element at a time, and we read from left to right, and so let's start with aluminum. Let's focus only on aluminum, and we see that there are 2 aluminums on this side and 1 aluminum over on that side. What do you suggest? Oh, why don't we put a subscript 2 underneath this aluminum right here? We'll just put a 2 right down here like that. And then we'll have 2 on this side, and we'll have 2 on this side. Don't you ever, ever mess around with the subscripts. Got that? Why not? Because if you change the subscripts, you're changing the identity of the material. Take H2O, change the 2 to a 3. It's not water anymore. Okay? It's something else. So don't mess around with the subscripts. You can change the coefficients all you want, but don't mess around with the subscripts. Okay? Let's change the coefficients. Oh, let's put a 2 right here. Yeah, check this out. This is showing us how it's not balanced. We have 2 aluminums and 1 aluminum over there. A solution? Let's put a 2 right there. And that gives us 2 aluminums now. Now the aluminums are balanced. We're done. That was easy, wasn't it? We're done with what? We're done with the first element. Let's move on to the next element. Okay, aluminum, then comes oxygen. Let's make sure the oxygen's balanced. We have 3 on this side, and we have 2 on that side. I want to give you a hint on how to do this when you have an odd even. Look, this is odd subscript, this is even subscript. You're over here. What you can do is you can look over the other side and see what that subscript is. And say, oh, I see a 2 over there on the oxygen. I'm going to borrow that 2. And I'm going to put the 2 right here. Got that? And you could be over on this side. You're wondering what coefficient to put here. Well, look over this way and you'll see there's a 3. Go ahead and borrow that 3 and use that right here as your coefficient. Okay? Yeah, this is what you saw. A 2 here. Oh, note that this 2 means you have 2 of these molecules. And this 3 over here means you have 3 of these molecules. So you're changing the oxygen, right? At the same time, you're changing the carbon. Don't worry about the carbon. Why? Because you're focusing on the oxygen. Just the oxygen. And as we have it, putting a 2 there and a 3 there balances the oxygens. Check this out. We have 2 aluminum oxides. How many oxygens is that? 1, 2, 3, 4, 5, 6. How many oxygens over here? 1, 2, 3, 4, 5, 6. We're done. We're done with the oxygen. We have other elements to contend with. Now, what's up next? The carbon. Now, we started with a more complex formula first, and we're ending up with a carbon, which is a simple formula. Why? Because we can change the coefficient in front of the C without messing up any other element. I can put any number I want here. I'm not going to mess up any of the other elements. And so what number do I want to put there? I have 3 carbons on this side of the arrow. I need 3 carbons before the arrow, so I'm just going to put a 3 there. We're done. We're done with what? We're done with the carbons. And we're done with our first pass. We've gone from aluminum to oxygen to carbon, all the elements that are within this equation. Time to start over again with our next pass. Okay, so we go back to the aluminum and we see that we have what? 4 aluminums on this side and 2 aluminums on that side. Wait a second, didn't we balance the aluminums before? Yeah, that's right, but we also messed it up as we moved on to the other elements. But you didn't worry about that. Well, we're coming back to it. So let's focus on the aluminum. And what do you suggest? Hey, let's just change this to a 4. And there you have it. And then you make sure your oxygens are balanced. You make sure your carbons are balanced. And that's a second pass. And then you might consider doing a third pass. Heck, you can grade this yourself, you know. Just count up the atoms. And if you find that it has the same number of types of atoms on one side as it does on the other side, you know you have your equation balanced. Perhaps what's most important in this section is that you understand why it is that the equation needs to be balanced. And that has everything to do with the principle of the conservation of mass. The number of atoms you have before a chemical reaction must be equal to the number of atoms you have after a chemical reaction. Because all a chemical reaction is a rearrangement of atoms. Not an addition or subtraction of atoms, but a rearrangement of atoms. And that's it for this section. Good chemistry to you.